Hi everyone, my name is Jun Is a first-year master's student at Komiya Laboratory. Will give a presentation titled Morphological Analysis of Japanese Hiragana Sentence using the Bi-LSTM CRF model. The table of content looks like this. First, I explain why we are doing Hiragana sentence morphological analysis. Next, I explain the experiment. After that, the result of experiment are explained. And finally, a discussion is given. Explain the background. The accuracy of modern morphological analyzer is very high, and there are systems such as Makeup, Chasen, Qt, and Juman. However, these systems were developed for kanji-kana mixed sentence, so they can't analyze only hiragana sentence. In addition, there is a need for this research to analyze the sentence of foreigners who have just started learning Japanese and elementary school students. Modern morphological analysis is done either by the beta-B algorithm from lexicography or by point prediction. The above text is morphologically passable, but converting it to hiragana makes it more difficult. For example, in this sentence, it is difficult to classify whether the meaning of picture. Even if you can't classify it, you need to estimate what it means. There are multiple types of character in the Japanese language. Kanji is script imported from China. Hiragana is a Japanese character formed from Chinese characters. Katakana is likewise a Japanese character. Usually, the character type is a clue, but not if all characters are in hiragana. In this study, we use the Bi-LSTM CRF model to create a morphological analysis model. Explain the experiment. First, let's discuss the experimental data. As training data, we use Wikipedia data and Wikipedia converted to hiragana data. We also use BCCWJ data as test data. 12 different data sets are used in BCCWJ. We also use the data from Yahoo Answers as training data. In this experiment, we trained and fine-tuned the model multiple times using Wikipedia data and Yahoo Answers. In other words, we created multiple models. We then evaluated the generated model with 12 different types of data from various genres. Explanation of BCCWJ will be given in the next slide. Here is the BCCWJ corpus of 12 types. I will explain them one by one. Textbook is randomly sampled from textbooks used by elementary, junior high, and high school students. However, some specialized subjects in high school like agriculture and commerce are excluded. Book is randomly sampled of all books published in Japan during a 5-year period starting in 2001. Bestsellers are randomly sampled of books that become bestsellers during a 30 years period starting in 1976. Poem was randomed from subtitled work for 3 types of poems: tanka, haiku, and poem. Newspapers were randomly sampled from all newspapers published in Japan during a 5-year period starting in 2001. Yahoo Answers is a randomly selected sample of Yahoo Answers postings. Yahoo Blogs is a random sample of architecture data from the Yahoo Blogs. Reports were randomly sampled as report published between 1976 and 30 years. National Diet Minutes used meeting minutes data from 30,000 meetings held between the 77th and 100th Congress. Legal documents is a random sample of all laws published during the 30 years from 1976 and still in effect in 2009. Books is a random sample of books published during the 20 years from 1986 that are held in public libraries in Tokyo. The PR document is defined as the population of PR documents published in 2008 by 100 local governments selected from all over Japan. That's the BCCWJ description. Here is contribution. First, developed a morphological analyzer for Hiragana sentence using the Bi-LSTM CRF model. Secondly, examined the influence of training data of morphological analysis on texts of various genres. Third, demonstrated the effectiveness of fine-tuned using data from Wikipedia and Yahoo Answers. Fourth, demonstrated the effectiveness of fine-tuned using a model based on kanji and kanji-kana mixed text. In the following section, I'll explain the multiple model that we actually created. This is the generative diagram of the model used in this experiment. There are model A through F for a total of 6 models. We will now explain how each model is created. First, let's discuss training A. Training A was created using Wikipedia as training data. This Wikipedia consists of sentences with mixed kanji and kana. So the model to be created is capable of morphological analysis of sentence with mixed kanji and kana. We call this model the kanji kana wiki model. Next, let's look at training B. The training data used in learning B is Wikipedia converted into Hiragana. We call this model the Hiragana wiki model. Next is training C. The training data for training C is the same as that used in training B. We call this model the Kanji Kana Wiki plus Hiragana Wiki model. The above three models use the information from Wikipedia as training data. The next section describes the model using the Hiragana Yahoo answers. First, let's discuss training D. The training data for this training is the Hiragana Yahoo answers data that exists in BCCWJ. We will name this model the Hiragana Yahoo model. Next is training E. The training data for training E is from Hiragana Yahoo answers. We are also fine-tuned the Kanji Kana Wiki plus Hiragana Wiki model. We call this model the Kanji Kana Wiki plus Hiragana Wiki plus Hiragana Yahoo model. Finally, we will discuss training F. The training data used for training F is from Yahoo answers. We are also fine-tuned the Hiragana Wiki model. We call this model the Hiragana Wiki plus Hiragana Yahoo model. Explain the results. This is the training results. Here is a summary of the evaluation and micro and macro average for each dataset. The one with the best accuracy for each dataset is shown in this slide. Overall, the accuracy of the Hiragana Wiki plus Hiragana Yahoo model has improved. Here is a table with only the macro and micro averages taken out. We can see that the accuracy is highest on the right side of the table and decreases as we move to the left. If we apply this result to the previous figure, we got this graph. Only the three most accurate models are shown. This makes me think that Hiragana Wiki plus Hiragana Yahoo model is number 1. Hiragana Yahoo model is number 2. And Kanji Kana Wiki plus Hiragana Wiki plus Hiragana Yahoo model is number 3. This is true, but there is another story. The number 3 model, Kanji Kana Wiki plus Hiragana Wiki plus Hiragana Yahoo model is a generally good model. This is a table showing the total number of rankings obtained by the 3 models in their respective corpus. Indeed, the number of models in Kanji Kana Wiki plus Hiragana Wiki plus Hiragana Yahoo model that got number 1 is 0. However, this model has on second place 7 times, the most of all the models. We believe that this model has trained the largest number of corpus and is able to handle a large variety of corpus. In exchange, the overall accuracy is a little lower than the other two models, making it the third most accurate overall. Continue with the discussion in these results. First of all, between the Kanji Kana Wiki plus Hiragana Wiki model and Hiragana Wiki models, the accuracy of the Kanji Kana Wiki plus Hiragana Wiki model was higher than that of the Hiragana Wiki model, because the Kanji Kana Wiki plus Hiragana Wiki model was fine-tuned to the Kanji Kana Wiki model. This confirms the effectiveness of fine-tuned using the Kanji Kana Wiki model. Secondly, the accuracy of the Hiragana Yahoo model is the second best, which can be attributed to the fact that the training data used is BCCWJ data and the test data is also BCCWJ data. And between the Kanji Kana Wiki plus Hiragana Wiki model and the Kanji Kana Wiki plus Hiragana Wiki plus Hiragana Yahoo model, the Kanji Kana Wiki plus Hiragana Wiki plus Hiragana Yahoo model on the right side was more accurate. This confirms the effectiveness of fine-tuned using data from Wikipedia and Yahoo Answers. On the other hand, between the Hiragana Wiki plus Hiragana Yahoo model and the Hiragana Yahoo model, the accuracy of the Hiragana Wiki plus Hiragana Yahoo model was higher. When compared to the Hiragana Kanji Wiki plus Hiragana Wiki plus Hiragana Yahoo model, the difference is whether or not the Kanji Kana Wiki model information is present. Probably, in this case, the accuracy of the Kanji Kana Wiki plus Hiragana Wiki plus Hiragana Yahoo model is reduced by the noise of the Kanji Kana mixed text information. Summary. This is the summary. In this experiment, we created a morphological analysis model for Japanese Hiragana sentences using the Bi-LSTM CRF model. In this study, we examined the impact of training cases of morphological analysis on texts of various genres. Furthermore, we showed the effectiveness of fine-tuned using data from Wikipedia and Yahoo Answers. We also showed the effectiveness of fine-tuned using a model with kanji kana mixed sentences. This concludes my presentation. Thank you very much for your attention. Thank you.